So, good evening, everyone. First of all, I want to confirm, am I audible to everyone?
Yes, ma'am.
Okay. So, good evening, everyone. I'm Prableen Kukreja, PMRF scholar from IIT Tirupati. And now we are going with the week 4 of computer network course. So, let's start. We were at I think SNMP. We have to start today. We stopped with the SMTP. Any doubts till last lecture? Hoping that everything is clear. Let's start it. Is my screen visible? Okay. Any doubts till last lecture? Please write in the chat if you are having any doubt so that we can first continue that. Okay, let's start with SNMP then. What is the full form of SNMP? Yes. Before starting with SNMP, can you tell the full form of SNMP and the working of SNMP?
SNMP is Simple Network Management Protocol.
And what is the working of SNMP? Any idea?
It's a standard protocol for managing the network. Basically, it manages the IP addresses in the network layer. And
okay.
And it uses UDP.
Absolutely correct. So yes, you are absolutely correct. Let's proceed. As you told that SNMP is simple network management protocol. And as the name is suggesting that it is used for managing the network, and other thing is I can say monitor the network. So monitor means whether the network is fine, whether the health of the network or the capacity, whatever the network is holding, is it fine? So it has to monitor. It basically it allows the network administrator to monitor that. If I talk about manage, it will see about how we can make the bandwidth services if the network is suppose expanding, then how bandwidth service can be better, how we'll basically quickly respond to the network problems, I'll say. All these things about the networks, the problems with the network and all. If dynamically new network is coming, real time testing, network is expanding, and all these things comes under this managing part. Okay, yes, Diksha, it's monitoring and managing the network. Absolutely correct. And can you now tell me? I'll try to be like fast today because we are already behind. Like it's week 2, last lecture SNMP. We have to cover week 3 as well as week 4. I don't think so. Week 4 fully will be covered, but still we'll try somewhat to cover it. And some numerical questions also. We'll try to solve of flow control mechanism and all, like sliding window, stop and wait, and go back and SR protocol. I'll try to solve some numerical problems in the class, so it will be more clear to you. Okay, we'll discuss about that later. First of all, SNMP. What is SNMP agent? What is MIB? What is SNMP manager? What are their roles? Can anyone tell me? Yes, come on.
The SNMP agent is a software which is installed in the local device, which manages and store information in the local device and responds back to the manager and whatever request it sends to the manager, it gets a reply, and the manager also gives some connection-oriented request or maybe directions, commands you can say.
Absolutely correct. Yes, yes.
Yes, and the manager is the centralized server system which responds to individual agents and manages the whole network flow.
Absolutely. What about MIB?
MIB is the management information base. So, using this, the manager actually manages all the agents using the MIB number.
Yes, yes, yes. And Diksha, you're also correct, as you have written in the chat, and you are also correct. So, as you told me that SNMP, if I talk about the agent, it is basically running on any equipment, I'll say, collecting the information. Not collecting, I'll say maintaining the information. And if I'll talk about the manager, it is collecting the information from the SNMP agent. And MIB, that is basically a database in which information is there. If I talk about the whole process, let's see. So what happens? First of all, SNMP manager, it sends the request to SNMP agent. So we have a manager, we have a agent. Agent is within the device, which basically running on the device or network equipment. So manager, basically I can say in other words, in layman language, it is a client, which is an application, basically running an application. Agent is on the network equipment, whereas manager is on the application. Manager is sending the request to the agent. Then agent, what is agent doing? Where is the data, or where is the data stored? As you have already told that the data is stored in MIB, that is a database. So it retrieves the request from MIB and sends a response, I'll say. And then SNMP manager. Please mute yourself if you have any, if you don't have any doubt. Okay. So then SNMP manager processes and displays the data. So they are running, SNMP agents are running on the network devices. Manager is running on the application. Manager is collecting the information from the agent. Agent is retrieving from the MIB, which is itself a database. That is how the whole thing is happening. So MIB, it's a database on SNMP, that basically it is containing what kind of data? The device performance, I'll say. What is the defined device status? What are the objects? There was a word mentioned here, objects, that MIB manages the objects or specifies the managed objects or so. Like database is basically mentioning the objects there in the like storing the objects and all. What is the objects? They're just the parameters, I'll say of the device, nothing else. The parameters which are there in the device, that are the objects which are stored in the database, which is MIB. And then if I talk about the objects, each object, it is assigned as an object identifier, so that we can identify it in the MIB file in the database with like a simple OID, I'll say. It is in an MIB for the identification. And if I talk about the SNMP whole protocol, though we have done, but some requests and all, like how how the functions and all, like we have get request here and suppose get response. I'll just write, we'll discuss, though it's discussed in the class. Can you tell me what is this like whole procedure? Can someone tell me what is happening here? Here we have SNMP manager and here we have SNMP agent. Yes, come on.
So the manager is giving a request to the SNMP agent through the get request command, and through the get response command, the SNMP agent is replying back to the manager with whatever response is dedicated. And with the get next request, the further requests are drilled down into the SNMP agent through the port. Sorry, I missed the port. And again, the get response is actually giving the response to that particular request. And like this, the process is going on until there is at the end of the process, like no more requests are there. Then the request is then set up by the SNMP manager. And
yes.
yeah, I
Now,
just forgot the function of the set actually. But yeah, at last, when the manager is no more sending any kind of request, then the SNMP agent can stop it by using the trap command.
okay. You're absolutely correct for the get request command, that if we are requesting some parameters or I'll say objects, then we are doing that get request command. That is fine. And then a manager is basically requesting, as we studied here, that SNMP manager send the request to SNMP agent. Then SNMP agent retrieves the request from the database and it is sending back, basically responding back to the manager. And then get next request means whatever the request of the next objects and all, so on, it is going on requesting that. Set is basically modifying the value. If you have to modify the value of the objects, that we use the set request command. So again, the set request command is there. I think here it should be get response or so. I have written by mistake here. Okay. Get response. And then get response, and then the notification is sent by the agent to manager to basically trap it to complete that, the whole functioning. Now coming on SNMP versions. I'll come to the MCQ part, in which the other things which are remaining will be covered on. So we have 3 versions, V1, V2, V3. Can someone tell me what were the differences between Y V1 to V2 and Y to V3? What were the differences that we came up with these upgraded versions from V1 to V2 and then to V3? Yes, come on.
Ma'am, exactly I do not remember, but V1 was something related to the use of UDP, and some RFCs were mentioned, like 1157, something like that. And the version 2 was for community, so that's why it was named as V2C. And so it was basically for using in the community standard. And version 3 was version 3, it was no, I don't remember.
Okay, it's fine. So basically, if I talk about version 1 was simple. Like simple text based, like nothing, no security, nothing much, plain text based without encryption and all. Then they came up with the upgraded version, which was V2. Though again, they were unable to fix the security problems. No security problems were fixed. There was no encryption and all. But what was the difference between V1 and V2? That V2 was like allowing more bulk of data here. So that get bulk and all functions were added, and some other functions were added for the more data thing. And but in V3 we addressed the security part, the encryption and all parts. That is what the upgraded, like integrity, authentication, privacy, everything. Basically whole security part was, we were having many security features in this V3. That is how we came up with V1, V2, V3. And as you told that V2C is there because C referred to the community security. Basically, security issue was not still resolved, I'll say. It was again the whole, like the security issue still existed in V2, but in V3 we have numerous security features, I'll say. So this was SNMP, which I have explained like in brief. Managing, monitoring, we have agent, we have manager, yes.
Your screen is not visible.
Okay, I'm sorry. Wait a second. Was it visible in the starting? Now only it has gone, or it wasn't?
Last 1 minute or two.
Okay, then it's fine. Now it's visible?
Yes, ma'am. Thank you.
Okay, thank you so much. Yes, Diksha, you are correct. Without encryption, V2 security issue remained, and V3 integrity, authentication, and privacy were added. Okay. Now we studied about agent, MIB, and manager. How agent is running on the network equipment. Manager is basically on the application, and how the request is being sent by the manager to the agent. Agent is retrieving the information from the database and sending back to the manager. And this is whole process, get request and all, and how the versions were there. Now coming to the MCQs, in which we'll learn more about the SNMP. A second. This is SNMP. So first MCQ, what does SNMP stand for? This is simple only. Yes, write one and answer it. Why? Like, okay, it's fine, but yes, come on. Everyone have answered. It's basically C. It's not B. Many of you have answered B. It's not secure network managing protocol. In the starting of the lecture, maybe you guys have like started the lecture late or so. Simple network managing protocol. It's simple management protocol. It's not secure network management protocol. Okay, so there was a confusion between B and C. Please be careful. It's simple network management protocol. What is the primary purpose of SNMP? Managing and monitoring network devices, encrypting network communication, storing network logs, blocking unauthorized access. It's managing and monitoring network devices. That is what we have done. Sarah, be careful. Like it's A, it's fine. You can make mistakes, but it's like we have done now only that it's basically managing and monitoring the network devices. What port does SNMP typically use? Maybe you don't know. We haven't mentioned in the class. It's basically, Diksha, you're correct. It's 161. Though I'm referring it because it's not being taught, or it's just a cramming part. It's 161. Which of the following is not a component of SNMP? We read about 3 components now only. Which of the component we haven't read about? It's just now only we read. Absolutely correct. SNMP router. It's not the it's 4th question, Sanket and Likit. Absolutely correct. SNMP manager, agent, and MIB, the other component of SNMP, we have done now only. What is the role of SNMP manager? We have done that. We have SNMP manager and agent. What is the role of SNMP manager? It responds to client requests. It manages and monitors SNMP agent. It encrypts network data, or it acts as firewall. Majority have written fifth B. Yes, it's correct. It manages and monitors SNMP agent. What is the role of SNMP agent now? It manages network policy. It collects and sends data from network devices to SNMP manager. It stores user credentials. It prevents unauthorized access. Absolutely correct. It's B. It collects and sends data from network devices. They are on network devices and they are sending it to SNMP manager. Hope so these three components, they are basically cleared from your side. What does MIB stand for? Now only we have done. Management information base, managed internet bandwidth, main internet bridge, master interface box. It's easy only. They are very easy questions. Yes, absolutely correct. Which SNMP command is used to retrieve a single value from an agent? Get, set, trap, or walk? Kamlesh, please write question number as well. Sanket, we are doing 8th question. Yes, absolutely correct. It's A, get request. Which SNMP command is used to modify value of SNMP agent? Now only we have done. Someone was unable to yes, Nilanjan, you are right now. It's set command. What is the purpose of SNMP trap command? To manually request information, to send an alert or notification from an agent to SNMP manager, to encrypt SNMP traffic, to delete a network device. Everyone is correct. It's B answer. Everyone is correct here. Which version introduced authentication and encryption? I think we have already done these now only. Absolutely correct. V3 version. What is the default transport protocol used by SNMP? I haven't told. One of the student only told in the class now only. Yes, it's UDP. What is OID in SNMP? Object identifier, operating interface device, open internet domain, optical identification. Absolutely correct. 13th A. Which SNMP command retrieves multiple values in sequence? Get, next, get, trap, set. Absolutely correct. What is the primary difference between SNMP V2C and V3? Fifteenth question. Okay. Aman, okay. I think you've deleted. What's S? Maybe by mistake. Kamlesh, please write. It's MCQ, not MSQ. 15A, okay. Kamlesh, please write the question number. Okay. Yes, everyone is correct. It includes authentication and encryption. What does the walk command do in SNMP? I think we haven't done. Yes, come on. Okay. I think answers are dicey here. it retrieves all OIDs in the sequence. It's 16th B. Basically, it is used for retrieving the object identifiers. Okay. Which SNMP component act as a database of information? This is easy, pretty easy. Absolutely correct, everyone. MIB. Which SNMP command is used to get a list of available SNMP managed objects? Now only we have done the same question and just I have twisted the question here. Given a hint also. It's B, basically walk to get the list of objects. That is what we have done above as well. What is the role of SNMP inform command? Everyone is correct here. Kamlesh, please write the question number to acknowledge a trap message. Which of the following is not a feature of SNMP v3? Waste, absolutely correct. Majority have written, I'll not say everyone, majority have written D, faster data transfer. Encryption, authentication, message integrity, it comes in security, and security was the added feature in v3, and faster data transfer was not added as an extra feature. So these were the simple, I'll say, SNMP MCQs. Let's go ahead to transport layer now. So if I talk about transport layer, coming to this. So what do you think, like why we came up with the transport layer? What was not in the lower layers? What features were not there, or what is the transport layer providing? Which service it is providing that we came up with the transport layer? What is not provided by the below layers like network layer or so? Yes, Joseph, network layer is unreliable. Reliability, Aman, absolutely correct. So major, a major functionality, which is reliability, it is not provided by the network layer or the lower layers, which is provided by the transport layer. So that is why, or the other features also, we'll come up with that. So that is why we came up with the transport layer thing. And transport layer provides us various services as well, like end-to-end connection. It provides more reliability, I'll say. End-to-end connectivity it is providing, though we have done in the first introductory lecture about all these things, so I'll not repeat those things again about the network layer and transport layer, how the things are happening. I'll just come to transport layer services here. If I talk about the service here, though we have also studied packet switching and circuit switching, if you remember. If I talk about simple packet switching in the network layer, now what was happening in the packet switching, I'll say there is a router here. And suppose this is an intermediate router, which is sending the data also and which is basically receiving the data also. And now we also talked about the buffer overflow. which was the limitation. We okay, let's leave. I'll say like we have done in previous lecture about packet switching.
Sorry,
and
ma'am, we can't see
Ma'am,
your.
screen
We
is
can't
not
see.
visible.
okay, sorry about that. I don't know why this is happening. Okay. Sorry for the disturbance. Okay. We talked about packet switching as well as circuit switching in the previous lectures. So what was the major difference? Anyone remember about that? What was the major difference between packet switching and circuit switching? In the packet switching network layer, like what was the difference?
In packets, we don't have a dedicated connection, whereas we have that in circuit switching.
Yes, we were not having dedicated connection. What else?
In packets, the data is broken into different segments of packets.
Yes, data is broken
And
into sets of packets. Yes.
sent
What else?
via routers, they hop in between, and that's how it processes.
Any other difference?
There can be data loss and multiple packets can of different connections can use the same data like routers, so same network.
So basically there can be data loss, or I'll say here it's unreliable. You remember that we have done that telephone network or circuit switching was more reliable. We were establishing a connection, that is why, and it was unreliable. In this we also studied about buffer overflow, if you remember. Anyone, can you tell me what is buffer overflow? Yes, Joseph, absolutely correct.
Yeah, when the router, when the router becomes full with the packets at the receiving end, at the output port of the buffer, port of the router, when the packets become full, then there is no space to keep additional packets. So there's a buffer overflow and the packets get dropped.
Yes, absolutely correct. So we have incoming packets, I suppose, in the intermediate router as well as the outgoing packets as well. So suppose we obviously we have a finite amount of buffer space. I'll write in short here. Finite amount of buffer space. And if there is high load, more amount of packets are there, buffer will be full. And if it will be full, there'll be packet drop. That is what we studied in the previous classes. And that is why this is basically they are failing to support the reliability. And though, so coming to the transport layer, these were the network layer things. Coming to the transport layer, it is basically providing us the reliable data delivery. So and there are other reasons also, like one of the reason is buffer overflow, other reasons also for the packet drop or loss in the network layers. But in transport layer, coming to that only, the message basically it is sent correctly, it is monitored. I'll say monitoring is there, that if it has transferred to the end host or not, ensuring the reliability of that. If it is not transferred, it is basically retransmitted. That's what we'll see in the coming class, how this thing is happening. So I'll say the reliability is the reliability of data delivery is the most important service, or it is a prominent service which is provided by the transport layer. Coming to the other services, what are the other features? If I talk about connection establishment, we'll go like one by one to everything. Just a brief overview. What is connection establishment? Anyone? Any idea?
The three-way handshake.
Yes. Can you tell in more detail why we do this connection establishment or three-way handshake?
Yeah, first there is a TCP sync message that is sent, and then
Okay,
from
why
the
we are
sender
doing
to
that?
the receiver.
It's fine. We'll discuss in detail about that sync message or then sync acknowledgement message. Why we are doing that? Yes,
Because we want to know that the receiver has received the message.
absolutely correct. On point. So we want to ensure that the other end has received the message properly to make sure the other end is ready. And that is why we are doing the connection establishment, a hello message, or I'll say three-way handshake, the way you have described. Though we'll discuss in the classes, just I'm giving the summarized version of the services now. And this is why we are doing this connection establishment, so that to ensure other end is receiving the messages properly. So if both of you have established the connection, so we are sure that the other end is ready, basically. Now coming to one more thing. One more thing. Okay. We're talking about the reliability factor. If I don't want, like I want my application is as such, as we were discussing in like previous class, someone asked me that like why some applications don't require, like why we are not requiring reliability or so. It is basically application dependent, as we discussed in detail about that. So suppose application is like that, I don't want the delay, additional delay of this reliability and all those checking things and all, checking the data and all. The application don't need that reliability factor, like on minimal reliability is required. So that why it doesn't, because it doesn't want that additional delay. So if the application don't want the delay or don't want the reliability as well, what we'll do? Any idea what is clicking to your mind? Which protocol?
UDP.
Yes, absolutely correct. So UDP is like a wrapper of a network layer, I'll say, where we are basically doing the small checking only, because some applications don't need that additional delay because of the reliability factor. They want the application to be as fast as possible. So they think that reliability is not a primary concern for us. We'll go for the UDP rather than the TCP. Okay, coming to the other service, that is flow and congestion control. It's like if suppose sender is sending at the rate of 10 Mbps, and the receiver is receiving at the rate of 1 Mbps, then what will happen?
Ma'am, buffer overflow will happen on the receiver side.
Due to that, what will happen?
Packet drop will happen.
Yes.
Absolutely correct. So basically, network will be congested as we are pushing more and more data in the network, and wastage will be there. Packet drops will be there, as additional data will not be received by the receiver on the other hand, because sender rate is much higher than the receiver rate. So for that, sender and receiver, they have to agree on some point, so that transmission should only sender should send at the rate, I'll say they should agree at the point. Congestion will happen. So that sender should send the data that receiver can actually receive rather than dropping it. This is basically flow control that and basically congestion control will come to that. Basically flow control, and then congestion we already know about the traffic and all, how we can relate with that if multiple roads are there and how they are congested and all. We'll discuss that in detail further, the flow control and congestion control also. What is ordered packet delivery, the other service? Any idea?
All the packets are in proper order of their sequence numbers, and they are received in that sequence in the
Hmm.
receiver's end. It's basically in the TCP protocol, because the reliability is concerned over here instead of just only end-to-end packet delivery.
Yes, absolutely correct. So why we need ordering?
So no data is lost in between the transmission. So the ordered sequence is then useful, so that there in the transmission rate also no two packets, I mean the duplicate packet is transmitted properly, or some packet is not lost in the forbidden region. So all these concerns are required for the ordered packet delivery.
Yes,
So
yes,
we
yes.
can get a total complete trail of that.
Yes, Nilanjan, absolutely correct. We'll come to those terminologies. Whosoever don't know about forbidden range and all, as he has mentioned, we'll come to that as well. If I say now, the other question is: are the packets out of order? In first question: are the packets out of order? We are doing ordered packet delivery. Are the packets out of order? That's why we are doing ordered packet delivery. Why they are out of order?
At the receiver side, they could be out of delivery if one or two dropped.
Can I say that we have some this path, and suppose this path here the packet 2 and 3 are going, here the packet 1 is going, that path is faster, and the packet 1 will packet 2 and 3 will reach faster than the packet 1. That's why the packets are the packet 2 and 3 reached earlier than the packet 1. That's why they're out of order. Like this can be the reason here, packet, because we are doing packet switching here. Packet switching means they're doing by as you all have mentioned in the chat and you have explained that we are breaking into the packets. So one is following one route and the other is following the other route. So it may be the case that the later packets they are reaching than the earlier packets. That's why they are out of order, and that is why we require this ordered packet delivery as well. And okay, now coming to the connection establishment. Okay, 1 minute, I'll see the chat. Datagram with header, which are you referring? Data packets with the header. What is datagram, Sarah? Can you tell me? Okay, someone has written datagram with header. Can you tell me what is datagram? As you have mentioned. What is datagram?
It's in the UDP.
What about others? Come on.
So a datagram defines the individual units which we use in the which we refer to as the packets, which contains the message and all the information of the acknowledgement, these things. So in the UDP layer, I think the datagram is used while getting down from the transport layer.
Okay.
So individual packet units.
I'll tell you. Basically, we call data, we call as packets in transport layer. We call the same packets as datagram in network layer.
Yes, ma'am.
Yes, that is basically datagram. I didn't understand your question, Sarah, but as you have written data, okay, datagram with header. Yes, that datagram, if I'll have the header with that, Then we'll have the transport layer. Okay. Transport layer with the header is basically the network layer data. I didn't get your question. Datagram is used by the network layer after encapsulation. Absolutely correct, Aman. Now going to again connection establishment.
Ma'am, screen.
Don't know. Before it doesn't happen. Why it's happening again and again? Coming to connection establishment. So a client is there, a server is there. Connection request is sent and the acknowledgement is sent by the server. Is this that simple? What can be the issue here?
Packet drop by either request or ACK.
Why packet drop? What is the main issue? Okay, packet drop. Why? Like, okay.
And
Crash, basically. Yes.
The client has not acknowledged. Okay, yeah, client has to send another request to the server that it has received the acknowledgement from the.
Yes. So both are correct in one or the other way. Let's see. So suppose the packet is, as you told, that packet is dropped, corrupted, or somewhat happened, and the packet is not received as the other person has told. Then what will happen if the packet has not received?
Duplicate transmission.
Again, connection request was sent and we didn't receive an acknowledgement because it was crashed. Again, the request is sent. This is client. This is server. New connection request is sent. Now, what is the issue here? This is suppose connection request, like one was sent and again the connection request was sent. What is the issue now?
Server is confused which one to entertain.
Okay. Can you elaborate your statement? You are right. Which
So
one?
server does not know if it has to answer to the older connection or the newer So
okay,
that's the thing.
I'll write more clearly. Can I say that server is unable to differentiate whether it's the new one?
Yes, ma'am.
Or the duplicate
or a
one?
retransmitted.
Or retransmitted one. When it will be the new one and when it will be the duplicate one?
Duplicated one is when. A duplicated one is when the receiver has not received the packet and then it sender retransmits the packet again.
Duplicate could also be when the client doesn't think that it got an acknowledgement of what the request it sent. So it transmits again to see if
okay, and when is the new one?
New one is when maybe let's say client crashed
sequence number
or
will be different for the new one and the old one. For duplicate, it will be same, but if it is a new connection, then the sequence number will be different for this one, and so the acknowledgement will be also.
We don't have any sequence number till now.
Oh, okay.
So new means say client crashed and then it is restarting. It reestablished the connection.
Yes. So new means if the client the request crashed and it restarted, that is the new one. And duplicate one means if it doesn't reach, if the acknowledgement has not received to the client, or the client request has not received to the server, it is basically duplicate one. Am I correct by saying these two? The difference is cleared? Or I have made a mistake? I think so. It's correct only. So we have a yes, okay. So we have a confusion in that whether there was a crash and it's a new request, or whether it wasn't received. Suppose the packet has not received, so server basically it has received the multiple copies, so it's a duplicate packet. So it's a duplicate one, or it's a new one. That's basically a confusion here. So what are the possible solutions? Can anyone tell me how to overcome this issue? Okay, there was the solution given, port number. What was the issue with the port number solution? And what was the port number issue, solution first of all? What is port number? We have discussed in the last classes as well. Explained in detail.
It identifies the service. It identifies the service and the application.
It identifies the application. Yes, absolutely correct, all of you. Now, what is the how can port number solve this, and what was the drawback here? So it was like, yes, come on, Aman.
So the solution could be that for every new connection, or like we use a different port number, but the problem is that port numbers are finite.
Yes, absolutely correct. So for if it has crashed and the new connection is established, so different port number is used. But as you said, there was a limitation that port numbers are finite. Absolutely correct. Now, what can be the other solution? Unique identifiers.
Yes,
What is? Can you tell me about unique identifiers? Any one of you?
Is it referring to the sequence numbers which are unique?
Any identifier, basically. Basically, they are saying that okay, we will have a identify unique identifier for every connection request, or the sequence number also, or identifier. But they don't know how to which algorithm to generate which algorithm to generate this unique identifier, and there'll be an overhead also to generate them, and if the system, there were many limitations with that because of the overhead thing, how we'll generate this unique identifiers. So I'll come to the major thing. Now we came up with the approach, which is the solution 3, and which is the feasible solution, that kill off aged packets, or I'll say restrict the packet lifetime. Can anyone tell me what I have written here? I haven't explained, just written the same thing.
I'm basically giving it a time frame to act upon, and if it fails, then we will simply kill that particular packet so that it is not creating confusion in the server side.
Absolutely correct. So basically, if there is a delayed duplicate, we'll eliminate it because the lifetime of it is expired and it is taken out of the network. Easy words, can I say? It is taken out of the network, its time is expired, we are killing it, and that is how we are deleting everything of that delayed duplicate.
Ma'am, I have one question.
Yes.
While I was reading these solutions in the video, like port number is finite, and then the URI. So my question is that URI should also have the similar kind of issue, like finite, not only just overhead, but also it is finite, like it cannot be generated infinitely. Does this also have this kind of drawbacks or not?
Anyone, can you answer first? Let's make it an interactive one. Yes, come on. Can anyone explain what he's saying and answer the question? Come on. You're also studying? Wait, again, the screen has disappeared. 1 minute. What he's asking is, nothing in chat. Okay, Aman has written something. Yes, let's see. In URL, we use strings, so we have lesser chance of collision. Aman, can you unmute yourself and explain?
So I meant that we can use strings in the sense that we can create domain, subdomain, and all that, and in that we use strings, so we have much more flexibility. So collision chances are, or duplication chances are quite less.
So basically, we are reaching a computer first and then the application in the URL. Can I say that? So if reaching a computer and each computer will have not that much of applications, so not that much of ports, I'll say, the limited port numbers.
Yes.
So it will not create a confusion because the URL port specification is, as you have said, that whole, first of all, the domain, subdomain, it will be written and then the port number will come. So it will obviously be the unique one. And the finite thing will not be having a conflict here. If multiple services are there, then also, because we how many port numbers are there, first of all? How many bit port, port numbers are of how many bit numbers? Any idea? Basically, we have 1, 0, 2, 3, two port numbers. Anyone has written 65535. Okay, yes, you're correct. These are well-known port numbers, and total we have 65535 port numbers. And outside of this range, basically they're invalid, I'll say. You got your answer?
No, ma'am. Still, I'm not.
How we write the URL?
I'm starting with www dot the domain name, then the port number, and then the specific.
So we are reaching a computer, then we are reaching an application.
Yes, ma'am.
So we are reaching basically not a device, I'll say, not specifically mentioning to, and then we are reaching the port number, the application. So, and we have this much of 65535 port numbers there. Now it's not like everyone will have the, first of all, domain names and subdomain name as different one for the different devices. And now coming to the device, then we'll go to the port number. So port exhaustion, if I'll say, that will not be a scenario here if I talk about the URL thing. Is it clear?
Yes, ma'am. I think I've got this.
Yes.
So, ma'am, the issue of permutation is not over here in the domain name. So it will not suffer with the same drawback as like port number. That's what I have understood.
Yes.
Okay, ma'am.
So here we have the hop count, basically. Okay. So if I talk about connection establishment, how we handle delayed duplicates. So basically there were for the packet lifetime, how to restrict the, now we have done that. We have, the basic thing is we'll restrict the packet lifetime. If the packet lifetime is beyond that, we'll basically expire it, we'll delete it, the whole thing from our network. The lifetime will be expired of that delayed thing. Now coming to how we are doing it, we are not assigning any time or timestamp here. We are putting a hop count. After that hop count, like it started from 100 or so, and if when will it will reach to 0, the hops like this hops, and then when it will reach to 0, it will decrement each time, and when it will reach to 0, the hop count is finished, which means we'll drop the packet. Clear with that? Yes, come on.
Yes, ma'am.
What about others? Give thumbs up so that I can see how many of you are I got only one thumbs up and one what about others? You can raise your hand, give thumbs up, or write in the chat.
Oh, the hop count is not clear. Can you repeat if you don't mind? Sorry.
Sure. So basically, we have a lifetime. That why we are giving a lifetime, so that we should like for the delayed duplicate, we want, first of all, the problem was to differentiate whether it's a new connection or whether it's a delayed duplicate one. So we have to differentiate whether this is the already we have done the timeout and the last packet arrived now. This connection request, suppose there was a timeout and it arrived afterwards. For that, the solution we identify, if it's so much of delayed, the timeout is so much, then remove that packet, then delete that packet, expire that lifetime. To do that expiry, we have the hop count. Suppose it started from 100, it will hop and it will reach some other, it go to 99 device, then again the hop 98, and so on. When it went to 0, it means that we are basically dropping it, the time. Basically, it's a unit of time, I'll say. We are not specifically taking time, so that each device, like there'll be a confusion for the timestamp and everything. So we take the we took the hop count here. So whenever it is traveling, whenever the packet is traversing a single hop, it is decrementing at 1 unit, each time at 1 unit. And when the hop count is 0, it means its lifetime is over and we should expire that packet, kill off that packet. So the issue of delayed duplicates shouldn't exist. Is it clear now?
Yes, thank you.
Yes, ma'am, but one question. So the hop count, you have mentioned the hop count. Hopping is allowed only in the network layer, or I think it was in the network layer, right? Like hopping from one network to another, or was it in the transport layer?
It is in the network layer. It is in the network layer only. But here we are calculating with the, like, when we are going from one to other, we are calculating in the terms of hops. Though hopping is in the network layer. So and here it's basically end-to-end delivery. Will go to the last destination address. There will not go to the last destination address. That is the main difference.
So this hop count is different from that network layer hopping.
Can we what are others' views? Like, what do you think? This hopping is different from the network layer hopping? A second. I think hopping is the function, hop count is a function of network layer though. That is what I believe. But here,
Hops are measured by the number of routers in between, right? that they traversed. So
yes. Right. So it's network layer.
Network layer only. That's
yeah, I
what.
remember the point now. Yeah.
Yes.
Thank you, Aman.
I was also confused. Thank you so much.
Sure.
Okay. Now, we also need to ensure if the lifetime of the packet is done, then the lifetime of acknowledgement is also done. That is also the thing that we have to ensure that thing. And the other things are, okay, I think you were only telling the sequence number thing. There were two diagrams in the class which were discussed. Can you tell me about those? Can you tell me about these?
These are the forbidden regions of each of the sequence numbers as per their time frame.
Can you explain what is forbidden region and everyone to everyone in the class, so that everyone should understand?
Yes, ma'am.
Mm-hmm. Yes.
Well, the forbidden region defines the lifetime of a sequence where it is active in the network,
Mm-hmm.
so that no other sequence number can actually interfere whenever it is acting in that particular time frame and it is alive through that network. So that's why it is known as forbidden region.
And what are these? Can you tell me? What is this I have referred to? Okay, I got the forbidden region.
I cannot see your pointer. Which one you're referring?
Both of the diagrams I'm referring to.
Oh, so ma'am, the first diagram refers when the two connections having two sequence numbers are actually collapsing with each other in the same time frame. For suppose the the first connection having the sequence number 1 having a time frame of t1 and the second uh, sequence number 2 also starting with the same time frame, maybe t1. So there is a collapse in the forbidden region, which is shown by the intersection area, that one's ending time is actually colliding with one starting time. And the second one is when both of the sequence numbers have different starting points. So there is no collapse between the two sequence numbers. Like you can see the time t1 is different from the time t2 over here in the second diagram.
Yes, absolutely correct. So basically, I say that there was a time of collapse between the time that the packet lifetime was not finished and the connection two started, and here there was the, like, I'll say the sequence numbers were basically being utilized again. That is the main issue. Now, what can we do for that? What ideally we want? Can anyone tell me?
Ma'am, for the first we want that both start at different time, or maybe we choose different sequence numbers which are quite high in difference. So these are the two possible scenarios.
Yes. Just give me a just okay. We'll have 10 minutes break. I want to go. Like, my kid is crying, so let's have a 10-minute break in the session. I'll come back at 7:20. Is it fine? And we'll continue with the same discussion. Am I audible?
Yes, ma'am.
My screen is visible.
Yes, ma'am.
So yes, we were discussing about the sequence number, the how the sequence number is happening and all. So as you have told about the forbidden range and all, and there shouldn't be like there should if the forbidden range is basically overlapping, there's an issue. So we shouldn't be reusing in the same duration. There should be a gap to or we can say we should separate the time. Or the other thing is we should have the gap in the sequence number as well. That is what the ideal situation should be. So I haven't left something behind. Is it fine?
Yes, ma'am.
I hope so. I haven't left something. Okay. Okay. So there should be no overlap and everything. That's what we have discussed. What about, there were two problems which were discussed. Like a host being too fast or being too slow. Something like that. Some problems were discussed, like for the forbidden range. Can someone tell me in detail what were the problems and what was the solution? Like, okay, what were the problems? That host is sending too much of data, then there can be a problem in the packet sequence number. And if it is too slow, the data rate is too slow, then there is a problem. Can someone tell me in detail? Yes, come on.
Ma'am, if the rate is too fast, then there will be overlap in the time frame of the two data packets, and there might be some data loss in that case. And when they're too slow, then they might not be able to catch up, and there again might be some data loss because of that.
Okay, I'm referring here to the sequence number. What can be the problem in the sequence number? If the data is basically old, I'll say this old connection, the first connection, old delayed packets from the first connection, they are still existing, and it is very like fast. Suppose it's fast here, and the first one is fast. The host is sending too much data to the fast, and if suppose the other thing I'm saying is, okay, I think it's incorrect. The host is too slow, first of all. If the first connection is too slow, and here if the second connection is too fast. If it is there, the sequence number, again, they can be overlapping, can I say? Because if the data rate is too slow here in the first connection, the second connection, if it will come, it will use the same sequence number from the previous connection. Like I'll say they will enter the forbidden region for the next connection. And if it is too fast, the second connection, again, it will enter to the sequence number of the first connection. That is what I meant that host sends too much of data to newly opened connection, or I'll say the data rate is too slow for the previous connection. This previous connection, very slow. It is very slow. So when the new connection will be started, it's still existing there. So sequence number can overlap here. The other thing is, if the newly built connection, it is too fast, then the problem is that it is still existing. The first connection was still existing and the second connection came into existence. So the sequence number still can be duplicated. Is it clear? Or there are some like you're not able to figure out what I'm trying to say?
No, it's not. It's not. A little bit some more clarity and needed, please.
Okay. Maybe. Okay, now what I was talking about was the sequence numbers, like how to design the sequence number. First thing, like I'll start from the starting thing, like where, so that no confusion can be there, should be there. If I talk about the sequence number, how the thing is happening is, I'll come to that again. What we're doing is, we have a client, we have a server here. So it is requesting, the sequence number is given. Suppose the initial sequence number is 1000. Server is basically accepting the request number 1000 and it is replying back. Now, how they are replying? Again, it is requesting 1050. This is basically the sequence number and this is basically the length. It is basically accepting. Okay, I have accepted the request. Now you can send it. Now it is sending 1001. So it means that the next packet will be 1051, the sequence number and the length. And the next packet again will be 1150 if it is 100. This is how the things happen. Now the issue was the initial sequence number. How the initial sequence number will be there, and do the sequence number can be repeated or in the connection 1 and in the connection 2. How we'll do that, how we'll figure out that. So that is what we were trying to explain here. Now, can anyone again explain the things which I have explained with more clarity? So what I said, I'll try to explain now again. There was a connection 1. And then there was a connection 2. Now, there can be a confusion here for the connection. I'll one minute. Make it with more clarity. Connection 1 and this connection crashed. And the new connection was established, that is connection 2. This was crashed, now this is new connection. Now, it shouldn't reuse, I'll say the sequence number, these are the sequence number. It shouldn't reuse the sequence number, the connection 2 shouldn't reuse the sequence number of connection 1. Am I correct? Is it clear till now?
Yes.
Correct, yes.
Yes, ma'am, correct.
So, this shouldn't be reused. What can be the solution for that? For that, if like connection 1, one solution is, if the connection 1 has crashed, wait for some time. Have a wait duration, then start the other connection. Does it make sense?
Yes.
Because I know that suppose the sequence number here was the same 5 and here also the sequence number was 5, I'll unable to identify that whether it was from the old connection or the new connection. I'll think it was from the new connection because it has already crashed, but I got it from the old connection because there was no time difference. Now I waited for the time so that all the I'll say everything should expire here, so that whatever was transferring here, it shouldn't get transferred. Now, if I'm using the same sequence number 5 here, which was used here, it has already crashed. It will not be transferred now because I have waited for some time. The other part is, don't use the same sequence numbers. Like suppose I'm using till 1 to 50 here use 50 to 100. If I don't want to wait, there should be a gap in the sequence numbers. Does it make sense now?
Yes, ma'am. Thank you.
I think I was unable to deliver before. So this is the like thing of the sequence number part. And now the other thing was like the first connection. The other thing which was that the first connection 1, if I say, it shouldn't be that. I'll write in the other page. Flow and connection 2 shouldn't be that fast. So that sequence number shouldn't overlap. Can anyone tell me what does it mean now?
Simply, it means that in either case, there would be overlap and we will have duplicate packets, duplicate sequence numbers at some point.
Now, if connection 1 was there and it crashed and the new connection is established and the connection was very slow and the new connection started here, so there can be overlap between the sequence number, and again the same thing, connection 2 started very fast, so that again there can be a duplicate between that. So it shouldn't be that too slow and that too fast, like both the connections, if I say. So one more thing, that there should be a coordination between the sender flow and the receiver flow. Coming to the flow control mechanism, before that, let's go to the three-way handshake, as it was mentioned in the starting of the lecture by one of the person here in the class. Now, can you tell me what is three-way handshake? Can I say, yeah, connection request is sent? This is suppose host 1. This is host 2. Acknowledgement is sent. Like I have received this packet. And again the other sequence. And then the data is sent. I've just written. Please explain what I have written first. What does it mean? Can someone explain me? Yes.
It's like the three-way handshake. Like, so host 1 is requesting for some connection, which host 2 acknowledges, then it sends, actually it should send sequence equal y, which host 1 will then acknowledge, and then it will start the data from sequence X that originally sent.
So what does acknowledgement is equal to X? Like, can I say the acknowledgement X from host 2 verifies that it is of the same connection number X? Like this is sequence number X. This is the acknowledgement of X. Does it verify that it's of the previous connection which you have sent?
Yes, ma'am.
And similarly for the other one, the acknowledgement is equal to Y, verify that it is for the same connection, which the same acknowledgement which you have sent earlier by the host 2. That is how it happens. Now, coming to the connection request delayed duplicate. Let's see what is happening now with the sequence number. Suppose we have a connection request. The sequence number is X. And then I'll write, please can someone explain? Yes. Yes, come on.
Ma'am, it is sending the request from the host 1 with sequence number X to host 2, which it is acknowledging by sending acknowledgement of sequence number Y for the X sequence, and then when the host 1 is receiving that, it is um,
Why it's rejecting it?
it is not the desired one.
Absolutely correct. So what is happening here? Suppose this is the old one. Again, the new one is sent, but this is the old one which has reached to host 2. Now host 2 don't know that it's the old one. So host 2 sends the acknowledgement back. Basically, acknowledgement is equal to X. It refers to that, it sends about that sequence is equal to X. It refers to that, and he sent it. But the host one said that it was already like the old duplicate. I have already sent the new one. So it rejects that acknowledgement. Now host 2 knows that there is no point to establish a connection. That connection request is already the old one. Does it make sense? Or I should explain again? It's fine for me to explain again.
Makes sense, ma'am.
Aman, what you are referring to, host 1 reject as it is using sequence number X. Can you tell me, elaborate this?
Oh, it's host 1, not host 1. So it is rejecting because the sequence X is currently in forbidden zone. So
Yes.
host 1 is not using it right now.
Yes, it's old one, so that's why. Coming to the other case, suppose both connection request and acknowledgement are delayed duplicates, suppose, which means connection request, suppose there was a sequence number X, host 1, host 2, this was the old one, and then acknowledgement. Just wait for a minute. Sorry for the disturbance. The screen is again unshared, or okay, we were at when the connection request and acknowledgement both are delayed. Then what will happen? Connection request sequence is equal to X, and then the acknowledgement is basically sent. The sequence Y and acknowledgement X, and then suppose the data is sent. And it is also old duplicate. Now, can someone explain in detail what I have written? I haven't explained though. Just I have written. Can you explain? Am I audible? Screen is visible?
Yes, ma'am.
Yes, yes. Can you explain?
Yes, ma'am. So first from host 1, the connection request of sequence X is sent, and the acknowledgement is returned back from host 2 with the sequence number Y. And again, the same data having the sequence number X is being sent with the acknowledgement of Y to the host to, and because it is an old duplicate, the acknowledgement Y got rejected by the host one.
Absolutely correct. When it reached the sequence and the sequence number was Y, like acknowledgement was X, so it was basically rejected. The same on the other side, and because it was a mismatch, that's why it was rejected here. So by looking at the sequence number, we can identify that whether it's a duplicate one, or whether we have to reject it, or whether we have to accept it. That's the major thing of the sequence number. Coming to connection release. Connection releases of two types: asymmetric release and symmetric release. Can anyone tell me what is the difference between asymmetric release and symmetric release? Yes, come on.
Asymmetric is when one side hangs up abruptly.
When one party hangs up abruptly, yes, absolutely correct. And what is symmetric?
When they both disconnect via without without like having any data loss. So
So it's like host one is done and it says, okay, I'm done, I'm closing the connection. It doesn't ensure with the other host. That's what it will not take it. It will not take the data. It will say, okay, I'm done, and connection closed. Connection releases, like host one says, I'm done. The other party also says, I'm done too. That's how symmetric release happens. But they are basically, asymmetric is basically like problematic sometimes, as I think there was an example also. If it is asynchronous in nature, we don't know whether the other, like blue army and white army, we have seen like basically there is no, it is unreliable, I can say. I'll not explain in detail. If you'll have any doubt, you can read it. It's unreliable, I can say, because every party is taking their own decision here. They are saying, okay, I am done. They are not thinking of the other host here. But if I say about the symmetric release, they are reliable here, because they are asking from the other party as well. The same thing of the lost thing, again, I'll not go with that how the connection, if they are saying that data release and it's lost, the same thing, the retransmission thing will happen. That's the same way we have done earlier thing. So I'll not go again with that. Should I proceed? Is it fine for you guys? Should I proceed? Okay. So now, coming to the sliding window protocol, the main part. There are many questions, the flow control and okay, not sliding window, I'll say flow control and the reliable data delivery part. So what is flow? There are many questions which are in the competitive exams as well about this flow control and data delivery part, about these ARQ protocols, sliding window and stop and wait and everything. Important aspect of computer networks course. So what is flow control? Can I say that sender must not send more data what receiver can receive? That is what we learned now only, that sender should send that much of data that receiver can receive, so that there shouldn't be a packet drop here. Accordingly, sender should adjust the rate of transmission so that it shouldn't overshoot the rate of transmission, I'll say, to have the to ensure that there is no overflow or that part. And again, we have learned about the network layer and all, how they are basically not ensuring the reliability, and whereas transport layer is ensuring the reliability. One of the question, it was discussed in the class. I want the answer from you, I'll not tell. there was a question that if the error control or flow control, they are in the data link layer, then why we need in the transport layer? And the other thing was, if a data link, if error control and flow control is in transport layer, why we need in the data link layer? Why we need in both of the layers? Now, can anyone tell me the answer? Yes, come on.
Is it because it's unreliable in the other layers also?
No. There is no. I'm not talking about reliability. I'm here talking about the flow control here. Data link layer. If we have flow control, why we need in transport layer, and why? Okay, you're saying in the other layers. Okay. Can you elaborate your answer? Okay, just this is a homework problem. I'll ask in the next class how. I'll just give a hint. Like suppose, a sender is having 20 Mbps and the receiver is having 1 Mbps. That is what, there'll be a packet loss and all. And then we need, what is transport layer? We need end-to-end. Data link layer is hop-to-hop thing. Why we need in both of the things? That is what is the question here. Now it is up to I'll keep it as a homework problem. I'll be sure now. I'll ask this first question in the next class. The first question will be this only: why both of the layers are having the flow control mechanism? Like why if the transport layer is having then why we need a data link layer, and vice versa. Now coming to the mechanisms. Stop and wait, ARQ. Can you tell me about stop and wait ARQ? A flow control mechanism. Now we algorithm I am saying. Yes.
Ma'am, it is an automatic. Yeah, so ma'am, in this stop and wait ARQ, the sender waits for the acknowledgement after sending one frame to the receiver, and if it does not get in return, then only it will retransmit that frame, or it will send the next frame as per the acknowledgement provided by the receiver.
Absolutely correct. On point. So frame is sent here, acknowledgement is here. Basically acknowledgement, suppose frame is here 0, acknowledgement 1 means I want the next packet. Then again the frame is sent, acknowledgement is sent, suppose the same one, again frame 0, and it get lost. Then again it will retransmit after some timeout. So as you have said that first a frame is sent, then the acknowledgement is sent, then only the next frame will be sent. So it will first send the frame, then wait for it for the acknowledgement, and then proceed to the next frame. That is basically stop and wait protocol. Now coming up with the sliding window. What is the difference between stop and wait and sliding window? Can anyone tell me?
You can keep sending the packets without waiting for an acknowledgement.
Yes. So basically, it will not send the packet, like only one packet is not outstanding in the network. It's not like one packet is sent, we'll wait for the acknowledgement and send another packet. It's like multiple packets are there in the pipeline fashion, and we'll receive the acknowledgement parallelly. That is basically sliding window protocol. Why we need sliding window protocol over stop and wait protocol?
Please repeat, ma'am.
Why we need sliding window protocol?
To provide speed.
It provides parallelism.
Yes, speed.
Can send multiple segments without waiting for acknowledgement.
So yes, you both are correct for the speed as well as Like we don't have to wait for the acknowledgement after sending each of the frame. We can send it in a pipeline fashion. That's there. And one more thing, each segment, like they'll contain the sequence number from 0 to basically 2 raised to power n minus 1. That is the window size here. Okay, I'll come to that. So how this works, sliding window protocol, let's see the same example which we have done in the class. Then I'll come with the numerical questions of go backend and SR protocol. We'll do that. So this is the bounding box, the sending window. The frame 0 is sent. We received the 0 here. The window now is like earlier it was, earlier it was 0 to 6. Now it is shifted from 1 to 7. Like now it is 1, 2, 3, 4, 5, 6, 7. Oh, no. Sorry. The window is still the same. 1 minute. I'll tell you. Sent frame 1. 0 and 1 is sent. Then when we are receiving the acknowledgement here, then we are shifting it. 1, 2, because we know that 0th packet is already delivered. That is how it works. By mistake, I have written that, though I'll have the numericals as well, so that it should be clear by your end. So what we are doing is, when the acknowledgement of 0 is received, I'm sliding the window ahead. Like I'm having 0, 1, 2, 3, 4, 5, 6, 7. Again 0, 1, 2, 3, 4, 5, 6, 7. I was having the window 0 to 6. I received the acknowledgement of 0, that 0 has been received. I shifted the window from 1 to 7. The way it is basically how we are sliding it. Though I'll come to the protocols. This is how the sliding is basically happening. Sliding window thing is happening. I'll come to that. And once basically, suppose one more thing I needed to mention. We'll discuss. Okay, Vedic, I'll provide it at the end of the lecture. So this was the sliding window protocol and stop. Now coming to go backend and the SR protocol to have the more clarity with the concepts as well. Can anyone tell me the difference between go backend and SR protocol? Don't worry if you're not understanding. We'll have a lot of numericals so that we can understand the concept.
Instead of sending all the like 0, 1, 2, 3, 4, 6, only the selected for which we have not received acknowledgement, only those we will be sending.
Absolutely correct. And what about go backend?
We retransmit everything from starting to
The whole window.
sequence number.
I can say the whole window is transmitted again rather than saying from starting to end.
Yes.
Here, if I haven't received any packet or so, if it is lost, so the whole window will be sent in go backend. And selective repeat, as the name itself suggests, selective. I'll basically resend the selective packet only. Now coming to, let's go to the, I think so, numerical only, or I'm hoping that you have done listen to the lectures. and or I'll just summarize few concepts and then we'll go to the numerical part. We have outstanding frames, which says that the frames are basically transmitted but acknowledgement is not received. Like suppose here we were thinking like 0 is transmitted but we have yet to receive its acknowledgement. That is called an basically an outstanding frame. If I talk about the sequence number part, the maximum sequence number, I'll come to that also. So okay, if I have there was an example given. If I have max sequence number is equal to 3 and window size is equal to 4, is it correct? Or max sequence number is equal to 3 and window size is equal to 3, is it correct?
Window size 3.
Window size 3. What was the issue with the above one? Let's see. Though this was
Duplicacy happens with size 4.
Let's see in the detail what was happening. So suppose the window size is 4, which means like we have 0, 1, 2, 3. This 0 is outside. And now I'm basically transmitting this 0. I received it. Now I acknowledged for the 0 basically, but this acknowledgement lost, suppose. Here I'm transmitting 1. Again, the acknowledgement lost, suppose. The acknowledgement lost. Can anyone explain what I have drawn? And as you were saying, duplicacy. Now, can you explain this? Yes, come on.
Since all acknowledgement lost, it is understood that 0 already transmitted but not received acknowledgement of that 0 frame. Hence, one more time, since the length is 4, 0 is again transmitted.
So what is the issue if the 0 is again transmitted?
Because that is 4 instead of 3.
So basically 0 is again transmitted. Can I say there is a confusion? Now sender don't know that whether the 0 is the, like receiver don't know whether the 0 is the above 0, because it will think that it has, because 3 of the frames because the receiver has sent the acknowledgement for 0, 1, 2, 3. It thinks that I have already sent the acknowledgement here. Now this is the new frame, but it is actually not the new frame, because the sender will know that it hasn't received that. So it is basically transmitting the same frame. Sender is transmitting the same frame, but receiver is perceiving it as a new frame. Am I correct by saying this? What about others?
In other words, it's delayed duplicate, no?
Delayed duplicate. Okay. Not delayed duplicate. It's
Delayed,
not...
delayed we cannot say, ma'am, because
Yes.
this is already 0th frame transmitted. Since
It's
acknowledgement is not received, and again, like window size is 4, one more time 0th frame will be transmitted.
Absolutely correct. We can't say it is delayed.
It is different packet but with same sequence number. So cyclic kind of thing.
That's it. So again, I'll just tell you what is this. So basically 0, 1, 2, 3 acknowledgement was given and lost for all of them. Now sender, because it wasn't like there was a timeout, I'll say here, sender again sent 0th packet. Now receiver thought, okay, already 0, 1, 2, 3 acknowledgement is sent. Now this is the new packet. But actually it was a not new one. It was this old one only, But because of the acknowledgement not received to the sender, that's why it sent it again and receiver received it as a new one. But it shouldn't be the case. That's why what we have the max sequence number, suppose 3. The same should be the window size here. How it will help? The same case, let's study. So here 0th was sent, and then the acknowledgement was lost. Then 1 was sent. Please mute yourself. Okay. Then 1 was sent. Then 2 was sent. The acknowledgement lost. And now the 0th is sent. Because it doesn't, I'll tell you, 0, 1. It was 0, 1, 2, 3, 0. Here it was 1, 2. Because acknowledgement was not received here. It didn't receive the acknowledgement. So it sent the 0 again rather than sending the 3 here. So when this receiver received the 0 here, it came to know that this is the same packet because the receiver was expecting the 3, but the sender sent it 0. So the receiver came to know, okay, I received the same packet. Maybe my acknowledgement is lost here. So here the issue was resolved. Understood? How it was resolved? What was the issue, like what we have done earlier? Come on. Yes.
Ma'am, what if the sequence would be like 0, 1, 2, again 0, but still the window size and the max sequence length is
Can
okay,
someone
no.
answer the question? Why it can't be like that?
Window size is 3, ma'am, and timer is set over there.
Yes.
Got the answer?
Yes, ma'am.
Okay. So let's go through MCQs. Maybe numericals we'll solve tomorrow. Maybe in the next lecture, not tomorrow. The selective repeat is left for this week. Okay. We'll quickly go through the MCQs first. Whatever we have done till now. Connection establishment MCQs. First of all, how many messages are exchanged? Let me open the chat. Yes. How many messages are exchanged in standard TCP 3-way handshake? Simple
3.
only.
3, ma'am.
You don't have to speak. Please write in the chat with the question number. Everyone will write in the chat because there'll be confusion. Like question number, like 1A, 1B, 1, 2, 1C, 1D. Yes. Please write 1 also, like which question number you are referring to. Otherwise, there'll be again confusion. Yes, 1C, that is 3. The name itself is suggesting 3. Which transport layer protocol uses a 3-way handshake for the connection establishment? Absolutely correct. TCP. What is the first message sent by the client in TCP 3-way handshake? Though I haven't referred to, but someone in the class referred to this. Absolutely correct. 3A SYN. What does the SYN acknowledgement message indicate in the TCP handshake process? Absolutely correct. Server acknowledges and agrees to establish a connection. What happens if the final acknowledgement message in three-way handshake is lost? Absolutely correct. The server retransmits the SYN acknowledgement after a timeout. In TCP, what happened if a SYN packet is sent but no acknowledgement is received? The answer is B part. So client resends the signal after the timeout. What is the purpose of sequence number in TCP handshake? Majority of you have answered correctly. It is used for packet ordering and loss detection. In TCP connection establishment, what state does the server enter after sending acknowledgement? Absolutely correct. 8C, which transport layer protocol does not establish a connection before data transmission? Akash, please write the question number as well as the option. Absolutely correct, UDP. What is the main purpose of TCP three-way handshake? Absolutely correct, to synchronize sequence number and establish a reliable connection. What happens if two hosts simultaneously send sync message to each other to establish a TCP connection? Come on, no one is answering. Okay, yes, I think many of you have answered incorrectly, but I think 2 or 3 have answered correctly. A simultaneous open connection is established. We studied about asynchronous thing. Coming to flow control mechanisms. What is the primary purpose of flow control in computer network? Again, question 1. 1, question 1, not 12th. This is other topic, question 1. Absolutely correct. To prevent a fast sender from overwhelming a slow receiver, which of the following protocol provides flow control in transport layer? Absolutely correct, TCP. Which of the following is not a flow control mechanism? Everyone has answered correctly. Cyclic redundancy check. In the stop and wait flow control protocol, when does the sender transmit the next packet? After receiving an acknowledgement from the receiver. Absolutely correct. How does the sliding window protocol improve flow control? Absolutely correct. It allows multiple packets to be sent before waiting for an acknowledgement. Again, start from question number 1. What is stop and wait protocol used for? Absolutely correct. Both flow control and error control. In the stop and wait protocol, how many packets can the sender transmit at a time? Absolutely. How many packets can the sender transmit at a time? Why more packets? 1 packet. Stop and wait means 1 packet and then 1. C. Most of you, yes. What happens if an acknowledgement is not received within a certain time in stop and wait? The sender retransmits the packet. 3A. How does stop and wait handle the lost packets? Fourth question. The sender retransmits after the timeout. Fourth C. What is the major disadvantage of stop and wait protocol? Everyone has correctly answered it. Inefficiency due to waiting time. How does stop and wait handle duplicate packets? Yes, question number 6. Absolutely correct. Written by most of you. The receiver uses sequence number to detect. Which of the following is a type of stop and wait protocol? Absolutely correct. Stop and wait ARQ. Which layer in the OSI model commonly implements stop and wait? Someone is writing A and I think B, transport layer. Okay. If the propagation delay is very high, what is the impact on stop and wait performance? 8D as well. Yes, yes. I'll come to that in the next lecture. I was thinking that. Yes, you're correct. D as well. Okay. If the propagation, I was thinking that someone will answer it. Okay, yes. If the propagation delay is very high, I'll come to this transmission delay and propagation delay also. Let it be. Delay is very high. What is the impact on the stop and wait protocol? Performance decreases. 9C. In stop and wait, if the packet is corrupted, what action does the receiver takes? No one has written. Sends a negative acknowledge. I think negative is in. Someone is writing B, someone is writing C. Yes, yes. NAK is in SRA, selective repeat. Yes, yes. So what is the answer, B or C? Let it be a homework problem, maybe B. Okay, someone is writing B and someone is writing C. Think about it. Okay, I'll mark it and I'll ask you in the next lecture. I think C, though I answered B. Okay, think about this. 11th, I haven't properly written. Okay, let's go to the 12th question directly. What is an alternative to stop and wait that improves efficiency? 10th question, you have to think about it. Absolutely correct. Why is the stop and wait A, basically 12th A? Why is stop and wait inefficient for high-speed networks? Can I say the sender must wait before sending the next packet? 13th B. If a sender uses stop and wait protocol, what happens when an acknowledgement is delayed? Yes. The sender retransmits the same packet after timeout. What does the receiver do if it receives the same packet twice in stop and wait? Doesn't it request for retransmission? Or it discard the duplicate packet and resend the last acknowledgement? Yes, you are correct. Like many of you have written C or okay. It's basically B, discard the duplicate packet and resend the last acknowledgement. Okay. We'll continue in the next lecture. The SR and go back in. I'll not bring the MCQs for that. We'll solve the numerical problems so that the things should be clear with them. Rather than MCQs, we'll solve the questions. Oh, yes. I think someone has mailed me also. I forgot to reply. I'll share the drive link. I think the mail. Okay, I'll write below the YouTube video, or I think there's a sheet also shared with you in Swayam portal. There I'll share it. Okay, and someone was asking about the mail. This is the mail ID, and this is the YouTube channel name where all the videos are uploaded. Mostly I'll upload tonight or tomorrow morning. Thank you, class.
Thank you, ma'am.